Arithmetic operators are as you would expect: add, subtract, multiply, and divide. The one that you might not be immediately familiar with is the modulo operator, which produces the remainder when its left operand is divided by its right. These are all binary operators, meaning that they operate on two operands. If you're not familiar with it, an operand is just a mathematical term referring to the object or quantity on which some operation is performed. A modulo, or remainder, thus divides the left operand by the right operand and produces the remainder. At first, this might seem like an obscure addition to the core language, but in time you will discover that it's immensely useful for system-level programming, and in particular, the implementation of many algorithms. It also allows you to dabble with mathematical real numbers without actually using floating point values. All of these operators are left associative. That means given operators with the same precedence, the operators would be interpreted from left to right. Since plus and minus have the same mathematical and operator precedence, 5 minus 4 plus 3 is 4. This is the same as if we had used parentheses to make it explicit. However, this is not the same as if we explicitly interpret it from right to left. As in mathematics, operators have a relative precedence. Naturally, the multiplication and division have a higher precedence than addition and subtraction. So 3 plus 4 times 5 is intuitively and correctly 23. Again, this is the same as if we had used parentheses to make this explicit. But this is not the same as if we force the addition to be interpreted first. So these operators are pretty straightforward. Just make sure the right-hand operand for divide and modulo is never 0, otherwise bad things will happen. The relational operators answer questions surrounding the relation of different values or the truthiness of some expression. Are there more cats than dogs? Are there at least as many boys as there are girls? Were both Woodrow Wilson and Nikola Tesla born the same year? These are relational questions and produce true or false responses. Since C does not have a Boolean data type, truth is represented by 1 and false is represented by 0. Conveniently, C also considers anything that is not 0 to be true for the sake of decision-making. Computers, unlike some humans, do not believe in relativism. Something is either true or it's false. It's also useful to keep in mind that relational operators have a lower precedence than the arithmetic operators I talked about previously. So 5 plus 4 is less than 10 is true. There is no need to be explicit, but you can if you want. This is, however, not the same as giving precedence to the relational operator. In this case, 4 is less than 10 is interpreted as 1, which is then added with 5, producing 6. Logical operators connect two or more expressions to realize some compound truth. Taking their names from logic and mathematical conjunctions and disjunctions, the AND and OR operators provide powerful and concise building blocks for more complex decision-making. The logical AND operator returns true only if both of its operands are true, whereas the logical OR operator returns true if either or both of its operands are true. Expressions joined with the AND and OR operators are evaluated from left to right. This is important. This evaluation stops as soon as the overall result is known. So in the case of the AND operator, the right operand is only considered if the left is true. And in the case of the OR operator, the right operand is only considered if the left is false. This might at first seem like a minor footnote, but it's actually a significant feature and one that C programmers rely on heavily. It's sometimes called short-circuit evaluation, but I'll leave it there for now. Finally, the other thing to note is that the precedence of the AND operator is higher than that of the OR operator. So in this expression, even though evaluation occurs from left to right, parentheses always comes first, followed by the AND operator, and finally the OR operator. In some ways, the bitwise operators are similar to the logical operators. But in this case, the operators operate on individual bits rather than whole values, and the results are always bits rather than a statement of truthfulness. The bitwise operators are often used when interacting directly with hardware, such as for a device driver, because they allow efficient communication through machine registers, or when you are dealing with packed data structures such as those found on storage devices for file systems, and when implementing network protocols such as TCP/IP. The bitwise AND operator delivers a set of bits where each bit is 1 if the corresponding bits in the left and right operand are both 1. The bitwise OR operator produces a set of bits where each bit is 1 if either or both of the corresponding bits in the left and right operands are 1. Now the exclusive OR operator produces a set of bits where each bit is 1 if either of the corresponding bits in the operands are 1, but not if they are both 1. This might also seem like a bit of an obscure operator to have as part of the core language, but for the fact that it is vitally important for many high-performance algorithms, from hashing and encryption to graphics. Keep in mind that all of these operations map directly to machine instructions, so they are very efficient. The left and right shift operators produce a set of bits where the bits of the left operand are literally shifted left or right a certain number of bit positions depending on the value of the right operand. The main difficulty when using the bitwise operators is in visualizing the bit values, since C does not provide a literal representation for binary numbers. Programmers often use hexadecimal notation as the next best thing. Anyway, consider the numbers 170 and 90, which have these bit patterns, given an 8-bit byte of storage. 170 and 90 produces 10, as in 170 and or bitwise AND 90 produces 10. This isn't at all obvious until you look at the bit pattern. As you can see, 10 is the decimal value that is produced in the resulting set when you consider only those bits that are 1 in both 170 and 90. I won't try to describe the rest, as it's far easier to grasp simply by studying the table of binary values. Take a moment to look through the results and make sure you understand how the resulting values were produced. Up till now, all of the operators I've shown you have been binary operators. That is, they operate on 2 operands. But C also provides a useful set of unary operators, meaning they operate only on a single operand. It also follows that these have the highest precedence, since there's no question about which operator should be evaluated first. The logical negation operator transforms a truth into a falsehood and vice versa. If its operand is non-zero, it produces 0 or false, and if its operand is 0, it produces 1 or true. The bitwise complement or 1's complement operator produces a set of bits by inverting all of the bits in its operand. The increment operator adds 1 to the value of its operand. Similarly, the decrement operator subtracts 1 from the value of its operand. These both come in both prefix and postfix forms. In both cases, the effect on the operand is the same. The distinction is in the resulting expressions. The prefix forms return the value of the operand after it has been updated, while the postfix form first returns the original value of the operand before it is updated. Naturally, which one you use depends on which value you require in the expression. If all you're doing is incrementing or decrementing a variable, it's generally preferable to use the prefix form. This becomes more important as you move towards C++. It feels somewhat weird only introducing the assignment operators now, as we've actually been using them for some time. But in many ways, these operators build on what we've just covered, so it's appropriate to introduce them now in the context of what we have already seen. The simple assignment is intuitive. It simply assigns the value of the right operand to the left operand. The remaining assignment operators are essentially contractions, so you could write apples equals apples plus 4, or you could more concisely but equivalently write apples plus equals 4. The latter is preferred not only because it's concise, but because in some cases the left operand, in this case apples, isn't always such a simple expression. The compound forms of assignment ensure that this operand is only evaluated once. We've covered a lot of ground and a lot of operators. Believe it or not, there are even more operators, but this covers the bulk of them and all you need to know for now. Operators follow a strict order of precedence. In this table, the order, or the operators, are ordered by precedence, with the operators having the highest precedence appearing at the top. Also keep in mind the associativity rules. As I said, this typically defines the direction in which operators are evaluated, or the operand with which the operator is associated. Finally, use parentheses when you need to force the order of evaluation, or even if you are just a little unsure. There's no harm.